This video is on review on circles, and so we're starting here at slide, I believe we're 27, and these are just the formulas for arc length. So remember, arc length is just talking about the portion of the circumference. Remember, circumference is like perimeter, but only perimeter of the circle. So if you're looking at a circle and you wanted to talk about arc length, you would just be talking about going or tracing the circle for a portion of it instead of tracing the entire circle. We did formulas for arc length in both degrees and radians. So if we're in degrees, then you take the angle that they gave you over 360 times 2 pi r. Remember, r is the radius, and that equals the arc length. And if we're in radians, the formula was a little easier. You just take the angle in radians and times it by the radius, and that gives you the arc length. Okay. All right, so a couple of examples. Number 1, we're on slide 28, says find the length of the arc. So that's how I know that we're doing arc length, whose central angle is the number that you're going to put in for x. And since we're in degrees, 40 degrees, we'll use the degree formula. And the radius is 4. All right, so arc length equals x, which is 40, over 360 times 2 pi radius. And we're going to plug 4 in for the radius. Now, remember, we did these a couple of different ways. Sometimes the answers, and it just depends on if you're looking at like the multiple choice answers, sometimes they are in terms of pi, where we don't type the pi in the calculator. We just put pi in our final answer. And then sometimes they'll say round the whole arc length to like the nearest hundredths place, and then you'll want to multiply by pi. So we'll kind of look at both ways in Desmos just in case. So let's go to Desmos now so we can type this in. All right, so first thing you want to do is that fraction 40 divided by 360. And if we were going to do without the pi right now, we would skip putting pi in, and we would just do 2 times the radius. A lot of times, if this is the case, then they will have the answer in fractions. All right, so if I type everything but the pi in, I get 8/9. So one way we could possibly see this answer would be, remember, we still have to multiply by pi, so it would be 8 pi over 9. So 8/9 and then times pi. Sometimes you'll see your answer as like a decimal, and what they will have done is typed the whole thing in. So 2 pi times 4 times the radius, and then they'll ask you to round that. So usually that's like to the nearest hundredths place, so it would be 2.79. So that's another way we could see the answer. And it would just depend on, and both of these would be inches, since that's what we were in. It would just depend on the answer choices. If they wanted it in terms of pi, the answer would be 8 pi over 9. If they wanted it in decimal, the answer would be 2.79. Okay. All right, number 2, find the length of an arc, so still looking at arc length, whose measure is 2 pi over 3 radians. So now we're using the radian formula, which says arc length equals angle times radius. Now they tried to trick us, and they actually gave us the diameter this time. So the radius is half of the diameter, or the diameter is 2 times the radius. So we need to cut that diameter in half to get the radius. So 2.05 is going to actually be the radius. So again, arc length in radians says angle times radius. All right, same thing as before. We can type this in without the pi or with the pi, depending on the answer choices. They may want it in terms of pi, they may not. So first, I'm just going to type 2/3 times 2.05. And they may do that as a fraction. They may do it as a decimal. So this one, they could say 41 pi over 30. Or they could just go ahead and type everything in and do the decimal. So let's go back and type the pi in with that. All right, 4.29. And this one was in centimeters, so these would both represent centimeters, since that's what the radius or the diameter was in. Okay. All right, the next formula there is the area of a sector. So this is talking about we have a circle, and instead of finding the area of the whole circle, it's finding the area of a piece, almost like a piece of pizza or a piece of pie. X is still going to be the angle. We only did this in degrees, so only one formula, x over 360 times pi radius squared. All right, this one says find the area of a sector whose central angle, that's x, is 35 degrees, and the radius is 6, and we are finding area. So area of a sector, I'm going to do sector area, is x over 360 times pi radius squared. All right, and then same thing, I'm going to go ahead and do your answer either way you could see it. One in terms of pi, so the first time I type this in, I am not going to type the pi in. I'm just going to do 35 over 360 times 6 squared. Okay, and since I didn't type the pi in, that would mean that this answer would have a pi beside it, right? So 7/2 pi, or 7 pi over 2. Or they could type the pi in and give you a decimal as your answer. So let's go back and do that. So we could have actually typed the pi r squared, and we would get 10.995. So that is basically 11. So I'm just going to write 11. Okay. And these, this would be meters squared if you were looking at units. Area is square units, so you might see that in the answer choice as well. All right, last thing we did with circles says find the center and the radius given by this equation. All right, we had to complete the square when we did this. So remember we set up, we put the x's together first, and then we left a little room. Sometimes we drew a box. And then we did the y's. Same thing, left some room, made a box. And then any number that was on the left that did not have an x or a y, we actually moved it to the other side. And that's the only thing that went over there. Now, whatever we add in this box, I will also have to add to the right-hand side. I ran out of room, so I'm going to write it underneath, but usually we wrote it like we kept going, like plus box, plus box. To find what goes in the box, remember you take the b value, so like the number in front of x, and you first divide it by 2. and then you square that number. Right? That number that you get after you square it, it should always be positive after you've squared it, and it goes in the box on the left and the right. We're going to add 4 to both. And then technically you're factoring this, but remember the number you got when you divided by 2 helps you. So since we're doing x, I'm going to write x minus 2 because I got -2 when I divided, and then it's always squared. There's 2 of them. All right, and then we come down and we do the y's the same way. So for y, we're taking the b value, the number that's in front of just the regular y. We're going to divide it by 2 and then square it. We get 9 in the box. And then same thing, the variable this time is y. I got a -3 when I divided. And then there's 2 factors, so it's squared. On the right-hand side, you just need to actually do the math here, like add all these up. So -12 plus 4 plus 9 is +1. Okay. Now, they didn't actually ask me for this equation. What they wanted was the center and the radius, but I had to do this work to get down to the center and the radius. So the center, you always take the x and the y and you switch the numbers. So since it says x minus 2, then for the center, the x coordinate would be +2. And for the y, it says -3. So you always switch the sign and make it, for this one, positive. So remember these, you always switch the sign from the equation. All right, and then the radius, the number on the right side of the equals is radius squared. So radius squared is 1, so you square root that number to get the radius. The square root of 1 is 1. So the radius is 1, and the center is at 2, 3.